Are you ready to see the easy way to tackle a trig problem on an IB test? This is question 1 from the IBSL math test in 2022. The scatter diagram shows the number of daylight hours on the first day of every month for a year. A smooth curve was made from the points. The minimum is 0.8. The maximum is 6/16. The curve is defined as f of t, where t is time, in months. Give one reason why this curve is not quadratic. Please pause the video if you have not yet tried this question. There are a few reasons, but the first is that the shape is not a parabola because parabolas do not flatten out. This graph is cyclic. It is a wave, like sine or cosine. The function could be a cosine function. It would be the amplitude, A, times cosine of bt plus d. Amplitude is how far up or down the wave travels from its middle, or principal axis. Here the middle is at 12. Since the wave travels up to 16 and down to 8, the amplitude is 4. Question 1. Part B II asks, what is the period? The period is how long, along the x-axis, does one cycle take to complete. This wave starts at 0 and ends at 12, where it will begin to repeat. So the period is 12 months. Next question. What is the equation of the principal axis? As we saw early, the middle of the wave is at y equals 12. The next question says, hence or otherwise, find the equation of the line f of t equals the amplitude, A, times bt plus d. We know the amplitude is 4, but we will write -4 because this cosine graph is upside down. Think of how negative x squared looks compared to x squared. Here's a picture of cosine and negative cosine, for your viewing pleasure, of course. Now, let's tackle b, which has to do with the period. The period equals 360 degrees divided by b. Write an equation using what you know and solve for b to find that b equals 30. The parameter d is the vertical shift. Since the principal axis is 12, instead of 0, d equals plus 12. Number 1. Part D instructs us to find the length of time when there are more than 10 hours and 30 minutes of daylight per day. If you haven't tried this yet, pause the video and give it a try. It might take a few minutes. Let's look at the graph. We can see that the number of daylight hours goes above 10.5 in the spring, around 3, and back beneath 10.5 hours in the fall, around 10 or so. We need to write an equation and find the input values of the intersections of y equals 10.5 and our cosine graph. Use inverse operations and then arc cosine to find the value of t. Pause the video and take your time in figuring out the algebra. Try it yourself and make sure you can get the right answers. We know the distance from the start of the period to where the first intersection is. To find the other intersection, we can just subtract that distance from the end point of the period. We have done a lot of work. It can be easy to forget the question. We are being asked how long, the length of time, when the daylight hours are over 10.5 hours per day. We need to take the difference of the start and end. We can round our answer to 3 significant figures, which would be 7.47. Don't forget the units, which are months. Last question for problem number 1. The question tells us that the maximum number of daylight hours was exactly 16 hours and 14 minutes. It then says to calculate the percentage error in the maximum number of daylight hours. We were told the maximum on the graph was 16 hours. So we will take the difference of our estimate and the actual value, then divide by the actual value. Of course, we'll have to write that number as a percentage and round to 3 significant figures. The calculation here was done by changing hours and minutes into minutes. However, you could also write 14 minutes as a decimal, which would be 0.23 repeating. The minutes are just easier in this case. If you learned something, leave a comment. If you have a question, leave it as a comment. Consider subscribing and have a great day.